share with some.
Okay, thank you, everyone. Okay, so on the behalf of the organizing committee, at foremost, it is my great pleasure to welcome you everyone today at today's seminar. Thank you for your time, for joining us today. We are actually very delighted to have Prof. Ahmad Fauzi today with us to deliver his talk later, and we hope our session will provide valuable insights to inspire maybe new perspective or even foster future collaboration. Who knows, right? Before we begin, I would like to express also our sincere appreciation to the committee, to the HKI Jakarta, especially Dr. Afrizal as a chair of HKI Jakarta. And without further ado, maybe we can begin our today's webinar. But first of all, I would like to invite Dr. Afrizal to probably deliver his opening speech for us today. Dr. Afrizal, please, the floor is yours.
Okay. Ya, thank you, Bu Samira. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, distinguished guests, respected speaker, moderator, colleagues, students, and participants. It is my great pleasure and honor on behalf of the Indonesian Chemical Society or Himpunan Kimia Indonesia Cabang Jakarta to warmly big welcome all of to today's webinar entitled Multifunctional Nanocomposite Membranes for Enhanced Separation, Innovation, and Application. First and foremost, let us express our sincere gratitude to Almighty God for His blessing, which have enabled us together virtually today in good health and high spirits. This webinar reflects HKI Jakarta's strong commitment to advancing scientific knowledge, fostering academic collaboration, and promoting innovation in the field of membrane technology. Membrane science has become one of the most dynamic research areas in modern chemistry and chemical engineering, playing a vital role in water purification, environmental protection, renewable energy, biomedical applications, gas separation, and sustainable industrial process. We are truly privileged to have with us Professor Ahmad Fauzi Ismail from Universiti Teknologi Malaysia, UTM, one of the world's leading experts in membrane science and technology. His remarkable contribution to membrane research, particularly in nanocomposite membrane and advanced separation technologies, have significantly influenced the global scientific community. We sincerely appreciate his willingness to share his valuable knowledge and experience with us today. I'd like to extend our deepest appreciation to our moderator, Ibu Dr. Samira Hussein Almudi from the University of Indonesia for kindly guiding today's scientific discussion. On behalf of HKI Jakarta, I would like to express our heartfelt gratitude to all organizing committee members, our partners, and supporting institutions whose dedication and hard work have made this webinar possible. My sincere thanks also go all participants from universities. Thank you very much to join this webinar, research institution, industry, and government agencies who have joined us today. Your enthusiasm demonstrates our shared commitment to strengthening scientific collaboration and innovation. I hope this webinar will provide valuable scientific insight, stimulate productive discussion, inspire new research collaborations, and encourage the development of innovative membrane technologies that contribute to addressing global challenges in sustainability, clean energy, environmental protection, and industrial development. I encourage everyone to actively participate in today's discussion by asking questions, sharing perspectives, and exchanging ideas. Scientific progress is driven by collaboration, curiosity, and continuous learning. Finally, I wish all participants a productive, informative, and inspiring webinar. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, Dr. Afrizat, for the welcoming speech. Everyone, before we start the talk, maybe we can get a picture together. So if you don't mind, please, everyone, can you open your camera? Can you on the camera so we can see your
Virtual
beautiful
background
face?
maybe.
Ah, the virtual background?
Virtual background Pak Irwanto. Yeah.
You do have the virtual background. You
Yeah.
may want to
Wait a
put it.
minute. I want to upload to chat box. Wait a minute. Thank you.
Yes. Wait a minute.
You can on the camera and prepare your best smile.
Yes. Who's the photos? Pak Irwanto?
Yeah, Pak Irwanto will take
Yeah.
the photo.
I'll take a picture.
Okay. Give our signs, yes. Okay. Please change the virtual background.
I have upload.
Shall we count now for the picture? Pak Irwanto?
Ya. Oke. Kita akan hitung ulang.
Yep.
Silakan Bapak Ibu. 1, 2, 3. And the second slide. 1, 2, 3. Okay. Enough?
Okay.
Okay, looks good. Okay, thank you, Pak Irwanto, for the picture. So everyone, it's time for us to listen to the talk by Prof. Ahmad Fauzi. Before we start, please allow me to read his resume a little bit. So Prof. Ahmad Fauzi is from the UTM. He's also a OIC or Muslim Nobel Laureate. So he's a very distinctive professor. So when I see the CV from Prof. Ahmad Fauzi, wow, it's a very, very long, comprehensive, a very amazing CV. So I cannot read everything, but Dr. Fauzi is has a very high H index scopus. H index is about 100 to 123. And his area of expertise is around the membrane technology, nanostructured materials, hemodialysis, fuel cells, and others. And Prof. Ahmad Fauzi got his BSc and MSc degree from the University Teknologi Malaysia UTM, and he got his PhD from the University of Strathclyde, Glasgow, Scotland. And he's also won a lot of awards and honors. It's a very long list, so it's a very amazing. He's also a chairperson for the Henan Institute of Science and Technology. He's also the winner of National Technologies Award, Profesor Kehormatan at the Minnan University in China, and also won the Mustafa Prize Laureate in 2023. And he also got outstanding award for the several international conference. Prof. Fauzi also, if we see, has published hundreds of publications, international publications. He's also an adjunct professor before in Universitas Sriwijaya and Universitas UCSI Education. And we can see he's also board members of several organizations, international organizations. And yeah, it's a very amazing resume, Prof. Fauzi, you have there. So without further ado, probably I will allow me to invite Prof. Ahmad Fauzi Ismail to deliver his talk on the multifunctional nanocomposite membranes for enhanced separations, innovations, and applications.
Thank you.
Please, the floor is yours.
Thank you, Dr. Sambara. First of all, I would like to express my gratitude and thanks to Dr. Afrizal and all the HKI Indonesia for your kind invitation. Actually, this is my first time giving a talk in HKI, organized by HKI. Actually, I'm quite close, very, very close to Indonesian University. In fact, after Idul Fitri, I was in Indonesia for 2 weeks. In Indonesia, in a few university in Indonesia. And I'm always looking forward to collaborate. And a few of my Indonesian students already guru besar di Indonesia.
Yeah.
That's why it make me really proud of having a close collaboration with Indonesia, because I already produced more than 80 PhD students under my supervision, and more than 60 or 70 master students under my supervision. So among the student, majority came from Indonesia. Now, let me share my slide. Yeah. How to share the slide? Hold on. Let me share the slide. I don't know where to.
Maybe Pak Irwanto, can you make Prof. Fauzi as a host, co-host, probably?
Okay, wait a minute, I will.
Because I cannot share. Just now I saw.
Oh, Pak Afrizal?
Yeah.
Oh, Professor, can you make a?
Okay, I try. Okay.
Yes.
Okay.
Yeah.
Can you see that?
Yes.
Yes,
Okay.
ready.
It's showing now.
Yeah, okay, Alhamdulillah. Right. Let me. Right. As has been agreed by Dr. Afrizal and team, I would like to share the title of the sharing is called Multifunctional Nanocomposite Membrane for Enhanced Separation, the Innovation and Application. This is the overview of my presentation. What is a membrane? The development of nanocomposite membrane, how we evaluate the performance, what are the challenges, and the way forward if we would like to move forward the membrane that we have had developed. Now let's see the overview. Actually, for your information, my background is not chemical engineering, not chemistry. My background is, my first degree is in petroleum engineering. It's nothing to do with membrane. I know nothing about membrane. But when I was working only about 6 months before I came back to become the research officer in the university. I start to understand the membrane from Petronas. Petronas just like Pertamina in Indonesia, right? This how I started. For me, during my undergraduate, at that time, membrane subject was not even in the textbooks. I got my degree in 1989. I'm not sure whether Dr. Samira is already born or not. I got my degree in 1989. During that time, if I go back and check, the textbook is not even, the membrane is not even a textbook. So that's why every time when I was asked to give a talk, I would like to share this. And how does it work? The technology involves the separation of selected component from liquid, fluids, or gaseous stream by means of forcing the stream to pass through, the barrier, which is the membrane, due to a driving force over the surface of the membrane. That's been shown there. So this technology, now people realize that it is low energy cost now and capital cost, higher stability, easily scale up, because I had experienced this. Probably I can show you, if I'm not mistaken, also available in the slide. It's a bit robust and very easy to operate. For information, me and my team have had more than 70 systems nationwide in Malaysia. 70, not 17, 70 systems. And we receive almost 50 million ringgit, Malaysia, the budget or the order from ministries. Now, these are the application of the membrane, right? Pharmacy, water, medicine, food. Not many people realize that the orange juice or whatever juice concentrated by membrane technology as well. And in medicine, those who have a problem of acute kidney problem, hemodialysis, the heart of hemodialysis system is membrane, right? People do not have enough water now. Say for Indonesia, for example, I always said, how come we say, even in Malaysia, how come we say we do not have enough water? Seawater is available now. Why can't we use certain technology to convert the seawater to become drinkable water using membrane, right? So all the agriculture, energetic, electrolyte, fuel cell now, air protection, membrane technology for greenhouse gas, it will reduce the greenhouse gas emission. So our system for CO2 removal now being commercialized by Petronas. It was more than 10 to 15 years ago. We developed that in our membrane Amtech. Now, these are the processes. Either it pressure driven, just like you can see that pressure driven, MF, microfiltration, UF, ultra, nano, RO, or gas separation, and membrane distillation. You can see that membrane distillation, electrodialysis, capacitive deionization, PEM, proton exchange membrane fuel cell, is the way forward in the future, in the near future, and osmotically driven membrane processes. Because previously we only know reverse osmosis, but now PRO, pressure reduced, and forward FO, of course, gas separation. These are the currently available membrane processes. Majority of them already being utilized or being commercialized. Now, these are the filtration process. And now people always ask if they have a certain component that have a certain size. Of course, we can develop this, in Amtech, we develop all this. Majority UF nano RO gas separation fuel cell. Micro once a while. So if we can develop this, ladies and gentlemen, you can imagine that how important we are as a membrane technologist. And these are the application of such the filtration process that we develop. Now, market potential. People always said, "Oh, membrane is expensive." Once I was asked to share my experience in the Parliament of Malaysia, not probably in the Parliament, but in a meeting room belong to. If any ministries would like to call for expert to get sharing, I was asked that. Majority said membrane expensive. So I challenged them. Can you prove that? Can you prove that membrane expensive? They cannot answer my question. I always said that if we as a scientists or researchers cannot prove that certain thing is cheap or expensive, meaning that don't ever say that. Just keep quiet. Find the fact and figure. We always say this is expensive because why? Because we do not appreciate those being developed locally by our local researcher or scientists. We always tend to import. This import make the system 3-4 times higher than those developed locally. So in order to do that, ladies and gentlemen, my own experience, it took me more than 10 years. I was asked to speak in the front of ministries and minister. I used to do the pitching in front of Minister of Higher Education. He only gave me 10 or 15 minutes. After the pitching, he asked me, "Fauzi, how much you want?" I said, "I want 5 million ringgit Malaysia." Immediately, he gave it to me. But he asked me to develop the complete system. If that is in this slide, I will show you. Within 3 months. Can you imagine that? 3 months. That can serve 3,000 to 3,500 people in a certain village, are chosen by them. 3 months. I said, "Sir, give me 6 months." But at the end, me and my team delivered within 5 months. He insisted to come and officiate that. 5 million ringgit within 5 months, producing 500,000 liter drinkable water per day directly from seawater within 5 months. You imagine that. So I'll show it to you the market potential. You can see that. And the role of the membrane I think I always encourage people everywhere I give this talk, now in Indonesia, NKEA, National Key Economic Area. I'm not sure, but probably similar in Indonesia. This is in Malaysia. Agriculture, of course, Indonesia also have. Palm oil, of course. For your information, I did a project about 20 over million, co-funded by JICA and Ministry of Higher Education, dealing with palm oil. You can say that Japan, they do not have palm oil, but how come they funded us? You see how far, they're thinking forward. Healthcare, of course, oil, gas, and energy. This is the NKEA in Malaysia. What about in Indonesia? So I encourage all of us, all of you, need to understand, to know what is the national key economic area of Indonesia. Now, that is 11 industry in Malaysia, right? And these are the industry sector were prioritized in addition to the greater Kuala Lumpur. So all of this, I think similar in Indonesia. Probably Indonesia, the number is more than in Malaysia. Now, these are the module. Now, let me share with you. When we as a researcher, we need to understand, you know, the TRL, technology readiness level, the fundamental, you know, the upscaling, the pilot scale, demo scale before commercialization. So majority of us only develop membrane, flat sheet, hollow fiber, or whatever fiber. We test in the lab, we got the result, we publish paper. Wow, Q1, Q2, Q4. Wow, we are so proud. I'm not saying that I don't like that. I like publish as well. I have more than 1,600 papers. But what is the end of our mind? By conducting research in this particular area? Is it just publish a paper to get your promotion to become professor? Is that all? To me, no. Those days, I have to keep in my mind, keep to myself what I need to do. Because probably people those days cannot accept what I wanted to do beyond paper. Now, next week, I was asked by the Ministry of Industry and Science Cambodia to share the TRL initiative, the technology readiness level. So we have this module, we have a system. To me, ladies and gentlemen, this is only for me. If you don't like, it's up to you. If we only know how to produce paper, membrane, flat sheet, blah, 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 module, and we got a paper, a lot of paper in the lab, and we cannot still yet translate, transform it to something that beneficial to the community or industry, sorry to say, please don't consider us as an expert yet. Sorry to say that. Now, so in membrane technology, it is a multidisciplinary area. That's why I have students from pure chemistry. I have students from civil engineering, PhD student. I have students from mechanical engineering. I have students also from master in petroleum engineering. So they're multidisciplinary. I myself, I know nothing about membrane. But because of this, mindset of view from different angle, my late professor always said that, Fauzi, because you have different view, on this technology, probably one of these findings, your knowledge must be better than us. The late Professor Hamdani told me that, so don't worry. If you are come even from civil engineering, you can do this. Even from chemistry, it's much better. So fundamental. We need to do all this what I said just now. Fundamental, yes. Manufacturing. I sold a few systems, even to Indonesia, how to manufacture hollow fiber. And then we develop material for our membrane, Now I have a student, also a participant here as well. He's from Saudi. He's tried to do MOF. And he's trying to do halostite. And he'll try to develop CNT, carbon nanotubes. When I'm quite young those days, I develop the system to produce our own carbon nanotube in-house. And I won best of the best invention in the whole Malaysia those days, long time ago. by developing those systems. So these are to show to you that the technology is multidisciplinary. Now, development of nanocomposite membrane. There are challenges, you see. When we develop a membrane for water desalination or wastewater treatment, one of the big problems is fouling. Because the pore size of membrane is so small, 0.0001 micron. So all the water or the dirty water, they will stuck at the surface of the membrane. And this, fouling to study to how to, you cannot totally get rid of fouling because it's in natural. So what you can do is you can significantly reduce. I think maybe hundreds of PhD graduated by studying fouling. So because why? Fouling will decrease the performance and shorten the life of the membrane. So we need to do that. And the foulant, it could come from colloidal, organic, inorganic, biofouling, and particulate, which could be clay, fungus, virus, calcium, biological substances, and metal hydroxide. So this is the graph. The higher the selectivity represents the purity of the products after pass through the membrane. The higher the selectivity, the lower the permeability, which is the productivity. So how we can, consolidate this? We need high selectivity, purity. We also need high productivity, right? So that's how we develop. And if all of you would like to know more, there's a paper that we publish here downstairs, 2023. Inshallah, you can get it from the library. Now, this is the polymer. Membrane, it could become polymer, inorganic, The availability is very wide. And you can produce RO or MF, and availability of both hydrophobic and hydrophilic. And inshallah, easy to fabricate, reasonable, expensive, quite easy to scale up. Disadvantage, but there's a but here. Low resistance to organic solvent. Narrow pH because of its polymer. Low resistance to high temperature. You cannot operate at 60 degrees C or 50 degrees C, 8 hours straight away. Low lifespan is about 1.5 hours now. This lifespan has been increased. So some company, and I tested my own membrane, it could last about 3 to 5 years now. But that normally did not expose. But we know some company came to see me that they said their membrane can, the lifespan up to 7 years or 10 years. But practically yet to be confirmed yet. So the fundamental issue with polymeric membrane has been resolved along the enhanced removal of efficiency by cleverly using organic, inorganic, and hybrid nanofiller. That's why we need to go into the nanocomposite membrane. So the incorporation of these nanofillers in a polymer in view of forming a tougher membrane with desired excellent properties. So the nanopolymer or the nanocomposite material could be zeolite, carbon molecular sieve, silica, carbon nanotube, clay, and recently metal organic framework. The guy who won the Nobel Prize is, I know him. I met him. He also the winner of Mustafa Prize, but in 2019, if I'm not mistaken. I met him in King Fahd University. We were invited to give a plenary speech together with another two Nobel Prize winner those days, about 7 years ago. So all of this, we incorporated in the polymer and become nanocomposite. So the filler is always on top of the substrate, which is a polymer. Now, this is how we call engineered nanomaterial. So, nanomaterial are typically defined as a material smaller than 100 nanometer. So, below 100, then we call nanomaterial. So, it can be used, to treat wastewater treatment, high specific surface area. It contributes as well, high selectivity and reactivity, fast transport, and antimicrobial. And you can see that these are the categories of nanomaterial. Inorganic, these they are considered inorganic, and organic, polymer and natural, any downsides here, and hybrid, organic and inorganic. So for detail, you can check the paper. You can go and check my paper, or quite recently, the same paper, 2023 below. Right. You can see that there's the characteristics, the physical properties, and the chemical property of the material. So because of this, you can see that, when we add on the nanomaterial, the pressure could be the membrane could withstand higher pressure. Higher pressure, good selectivity, as well as good permeability with productivity. They also can, reduce the bacteria or remove the bacteria. And the stacked graphene oxide membrane, this is an important of nanomaterial. Certain bacteria, some of them almost 100% removed. Now, when we would like to develop mixed matrix membrane, it's not that difficult, but it's not that easy. So for the chemistry people like you guys, this is easy for you. However, after you develop that, you want to test in the form of the membrane, that is the challenge. So in order to do that, we need to understand. These are the step. The conventional composite membrane is like that. So the ideal one is like that. But this is a big problem. The material that we put in the membrane, normally some of them still stuck on the top. Not all of them well distributed, randomly distributed nanofiller. This is a problem, but you need the time. You cannot just say, by doing PhD you can know. Doing PhD to me is just a testing ground for you to develop a mixed method or nanocomposite membrane. But after that, when you come back to Indonesia, don't stop doing that, because the more you do, the better you are. The big problem is when we finish master or PhD, when we come back, we are busy, we're doing our teaching and research. We don't have time even to visit our lab. Dr. Abrizal know that my office, when I have office in the faculty, my office is in the lab. All right. So the development of the nanocomposite membrane. So multi-layer thin film nanocomposite. So we fabricate through deep coating, spin coating. So all these type of coating, it depends on what type of membrane that you want to produce. So after we produce this we call TFN, thin film nanocomposite, which provide flexibility to modify our membrane layer. So we distribute the nanofiller. And generally, the thin and dense layer is preferred for gas separation. And the thinnest layer provides shorter flow path for the gas across the membrane. So that's why the skin layer is only 0.2, 0.3, 0.2 or 0.3 nanometer, something like that. Very, very thin. You cannot even see. You have to see it under TEM. Right? So when we would like to move ahead to photocatalytic membrane, we need to understand why you want to do this, why you want to develop this. These are some of the application that I can share with you. Dye removal, where you want to use this in textile industry. For information, I assisted my colleague in a company that supply. So we help them to develop, design 2 membrane system. Now in operation for last 5-6 years. EDC degradation. So our team is among the pioneer team in Malaysia to study this EDC. So we publish and highly cited. Oil water emulsion. And secondly, representative of photocatalytic nanomaterial, what are they? TiO2, ZNO, and etc. Carbon derivative, GO, and carbon nitrate. What are the properties required? The photocatalytic activity in UV and visible light, low human toxicity, and high stability. So these are some of the aspect that I can share with you, right? Now, after we know all this, we need to evaluate whatever we have done. TiO2, PVDF, polyvinyl difluoride, photocatalytic degradation of nonylphenol. So we published this in 2016, or long time ago, 10 years ago. So we developed this, very simple those days, yeah. These are the membrane under SEM and EDX, we can see that. And we can see that the carboxylic nonylphenol, intermediate, initial condition. So we develop a dual layer, meaning that inside and outside there is a layer. So this, we use this as hollow fiber. It turns yellow after reaction, indicate that the light is scattered. After that, after irradiation, you can see that. Now, TFN nano filtration membrane incorporated GO, graphene oxide, for desalination. This is very important material as well. You can see that by having that, we can see the permeability increase with the GO loading. But however, there is a certain limit. I can share with you, even though nanometer is important, but please do not use more than 10%. Because use more than 10%, it will agglomerate easily. Agglomeration will reduce the selectivity and the productivity or the permeability of your membrane. This will, the people or the industry will say, oh, why your membrane is not performing? Because sometimes you can, we have experienced this, GO loading. The most probably 0.2, 0.3%, not more than 10%, right? So if you use 0.3, the rejection is about 95% for Na2SO4. And magnesium SO4 rejection 91%, right? So that's why we need to understand this. But in order for you to continuously, consistently produce this, you need to go back to the lab quite often. Practice how to make the membrane. Now, another one is we publish in Journal of Environmental Chemical Engineering. We use silver doped titanium nanotube photocatalytic hollow fiber membrane. Now, with that, we can produce, CO color removal increase from 46 to 84%. So when we do the pitching in front of industry, they were surprised. Wow, Malaysian scientists who can do that, yeah? See? This is very important for us to prove that, look, we, from Indonesian University also can produce something very impactful to the industry. So with that, with the antibacterial efficiency 95.6, 98%. You see, almost perfect, but produced only in the lab. Now, CO coated. You can see the polysulfone anti-fouling membrane. This is probably in desalination. So for that, by doing this, we can reduce the anti-fouling. And the inhibition zone is clearly visible. And the case of copper-coated membrane showed 23 millimeter of zone of inhibition. So this good inhibition is due to the release of high dosage of diffusible inhibitory compound from copper particle. So we prove that, you see, this is our membrane. And the copper is only on the top here, about 0.3, 0.4%. Now, for water reclamation for palm oil mill effluent. So we are doing it now. We have a certain industry that collaborated with us. And through my experience, palm oil defeated our knowledge in our textbook that we knew from textbook. The higher the pressure, the higher the palm oil that when we use a membrane, it is not what we understand. Sometimes we said we pressurize higher pressure, more the productivity, but not for palm oil. Something somewhere different. This Allah give it, you know. So we are still doing it now, and we hope that within sometime next year we can understand what is the meaning of that, specialty that defeated our knowledge as we learn from our textbook. So we use technology like nanofiltration that we would like to test. Can nanofiltration solve the fouling problem dealing with palm oil? So at the same time, we simultaneously recover water and degrade the pigment that lead to development photocatalytic membrane. So in fact, in palm oil, what we propose for JICA approved, we promise, inshallah, to deliver to them at least 4 technologies out of this palm oil mill effluent or POME. So this a project that I mentioned just now. So the title is Development of Palm Oil Mill Effluent, Treatment System for Sustainable Energy Production and Resource Recovery based on Material Innovation. So some of the material that I mentioned just now, we use it. So during my presentation, I did mention that Indonesia is a number 1, Malaysia number 2. But the problem is why Japan funded this project, whereas they don't have palm oil. This is a certain amount, 7 million, 47, 12, 20 million. Still ongoing, inshallah, until next 2 years. And these are the projects that I mentioned just now, 4 technologies that we will, inshallah, deliver by after completing this project. So microbial fuel cell, water reclamation technology, biogas, and neutron recovery or heavy metal removal. And these are, we also have a big project funded by National Hydraulic Research Institute of Malaysia for EDC. I lead this project as well. I think I forgot the amount given. Finished about 1 or 2 years ago, and we are among the pioneer developing the technology to deal with EDC, because EDC very very dangerous. Say for example, our ikan dalam sungai, they can change, daripada jantan ke betina, betina ke jantan. This very very dangerous. You could imagine if we always drink the water that contain endocrine disruptive chemical. Now, next, what is the key challenges now for nanocomposite material? The substrate of the membrane, modification and post-treatment. What are the modification? And selection of nanomaterial. It's very important. Then when we know this, we can handle this well, inshallah, then we can produce the desired TF and thin film nanocomposite membrane. The challenges are we need to close the gaps. What are the gaps? Agglomeration, as I mentioned just now. You cannot use up to 10% of the nanoparticle. Additive functionalities of monomers and nanoparticle. Alignment and orientation of nanoparticle. My PhD in this area, is it you align? Is it menegak atau tidurkan dia? Yeah. And reproducibility. The last one is the most difficult because if you want to upgrade or translate this, reproducibility is very important. Otherwise, people might, industry might not, confident in whatever we produce. In order to do this, you always need something somewhere, somebody that always be there to produce. Say, for example, we came back from PhD and we don't do that within 6 months. Probably our skill also deteriorated. Now, when we want to commercialize, people always ask me to share my experience commercialization. In fact, on the 20th, next week, I'm going to share as well. What is challenges? Upscaling and retrofitting. Fundamental, for example, you need 300,000 ringgit Malaysia funding. But for upscaling, probably you need 1 million. And then pilot, probably you need 2-3 million. And then after that, you need to have a demo unit. Probably you need 5 to 6 million. Majority of people do not yet fall into that.
Setiap gerakan dihitung dengan cermat agar tidak ada celah sedikit pun.
Yeah.
Di sisi kota lain,
So,
Abu Nawas sedang menikmati teh hangat di beranda rumahnya. Ia mengobrol santai dengan beberapa tetangga. Sesekali
apa yang bercakap
tertawa
Indonesia
mendengar
ni, ya?
cerita lucu anak-anak yang menirukan kejadian di pasar.
You
There
can,
is
Ia tampak tenang seolah
somebody
tidak
talking.
ada persoalan yang sedang
everyone,
mengincarnya.
could you please
Namun,
mute your
saat
speaker,
salah seorang
please?
tetangga bertanya, apakah Tuan tidak khawatir Raja Penulis akan mencoba lagi?
Pak Srianto, Pak Srianto, could you please mute your speaker?
Okay.
You?
Thank you.
I'm sorry
So,
for that.
uncertainties in the market penetration. That's why I'm for my slide. I'm talking about the market as well. And inappropriate risk and safety evaluation. I understand that we as a researcher, probably we are not up to the level that we can evaluate the appropriate risk and safety evaluation yet. But if you have that in mind to commercialize your products, you need to understand this. And to trigger emerging environmental issues associated with nanomaterial. People always ask, you put a carbon nanotube. But during the separation process, it goes. I always receive this question. So these are our challenges. But on top of that, the opportunity are heighten the water treatment performance, long-term economic prosperity. If you can do that, if you can recover the the water that they discharge, we can recover 50%. That the thing that we have done it in Malaysia, 50%. So the company, promote that in the newspaper. So their income, the business, improve because of that. Continuous sustainable development, of course, Membran can do that. What about other technologies? And new industry revenue? We need to inform them if we have had that idea. Tell them. In order for us to tell them, they will ask you, have you had experience on that? That is our problem. But take that as our opportunity as well. Now, this is our strategy. Yeah. Our strategy in AMTAC, exploration of advanced material. We need to explore innovative material fabrication and modification of the material. Next, we need to design the membrane, the process optimization, improve based on emerging material and membrane design. Next, we need to have this university industry collaboration. Difficult, but not impossible. So I was with a few when I was become a rector in 2001. I was in Bandung. They asked me. Beside me was the former rector of Universiti Indonesia, former rector of Unpad University, a few more. They asked me. They have look at my background. I have a lot of industrial collaboration. Now, if I can share with you, these are also culture, but my culture is, you can see my slide. I only mention my name, right? Dr. Samira? Ahmad Fauzi Ismail. Betul?
Yes.
Not Profesor, Doktor, Dato, MS, STS, blah, 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 tak ada. Betul?
Betul.
So, one of the mentor for commercialization, my mentor was from industry. The industry know who you are. You don't need to put all this title. I mentioned that masa di Bandung. Sorry, this is my own, observation. Even in my business card, only my name. Of course, you can put your, whatever degree. But in Indonesia, your culture is different. I'm not blame that. You're different. But if you go into worldwide, even grand professor, they only mention their name, right? They don't even mind. Of course, when you introduce people, you can do that. But you yourself, when you shake hand, just say, I'm Fauzi. I'm from UTM. So I'm doing research in membrane. That's all. And then alignment to national and global key niche area. Just I mentioned NKEA. The proposal must address one of the NKEA, not the proposal for you to get promotion. Because we get funding from the government. The government gets funding from the taxpayer money. Taxpayer money, who are the taxpayer money? The people, the rakyat. So those who really get back what they invested in us is the people, the community. So these are the integrated approach that I would like to share. Positive industrial attitude, dissemination, exploitation of the nano safety, establishment of long-term roadmap, and integrated research and development. This is a video that I would like to share before I end my talk. This is UTM. Dr. Afrizal already came here. Here's the main entrance. This is AMTAC. He's my former student. This is what we do in AMTAC. This is a system that we built. Material fundamental until commercialization. These are the product that we produce almost every year. Ini slide lama ya. And this will help those in the village that do not get access to clean and drinkable water. That is our system. This is our system. Our staff there, student, and research officer, research assistant. Treated water. You can imagine that the student cannot get access to drinkable water. And I have my own spin-off company, Membran Teknologi Malaysia Sendirian Berhad. How to huh? Yeah. As a conclusion, the development of nanocomposite membrane represent a breakthrough in membrane technology. So the introduction of inorganic filler into the membrane shows attractive outcome, which improve the membrane performance in terms of productivity and selectivity, the quality of the products. So the main challenges is, of course, related to agglomeration of the material and their poor reproducibility from batch to batch. That's our challenges. Now, more research still needed to develop nanocomposite membrane with greater performance efficiency, reliability, and stability for industrial and community implementation. That's all from now. Before I end, I would like to say saya mohon maaf kalau semasa saya deliver terkasar bahasa ya. Saya mohon maaf, bukannya niat saya, tetapi sometime during presentation certain unseen word disappeared. With that, saya mohon maaf. Begitu saja, saya ucap terima kasih sekali lagi pada Dr. Afrizal dan juga moderator kita, Dr. Samira, dan all of attendees or participants for spending your time listening to my talk. Thank you very much. Matur nuwun. Matur sakalangkong. Thank you.
Thank you so much, Prof. Fauzi, for a very inspiring and comprehensive presentation. May we give a round of applause, virtual applause, everyone? Thank you so much. Now, I'm sure we can all agree that this talk has given us a more deeper understanding about the membrane technology. Is particularly interesting to me because your talk is totally about the research itself, but also all the way to the strategies of the commercialization and the challenges and everything. So now we would love to hear from the participants probably. So this is a great opportunity for you all. If you want to ask questions or share your thoughts or any, concern or anything, please don't hesitate. Do we have a question from the floor, please?
Already the question on the chat box.
Okay.
Yeah.
Maybe
Okay,
we can
I can
give
see
to
that.
we can give to Bu a second.
Yeah.
Just now
Yeah.
someone raised their hands. Bu Sheda, Bu,
Yes, me.
please.
Okay, thank you for the time. Thank you, Professor, for your inspiring presentation. My name is Shelda, and I'm from Universitas Patimura, Eastern part of Indonesia. Yeah, and I have a question regarding to the multifunctional nanocomposite membrane you presented in terms of scalability. Reproduction and reproducibility. What do you see as the most promising bio-based precursor for future membran fabrication. I mean, at industrial scale.
Yeah.
It's my first thought. My second thought is my research background in bacterial cellulose-based nanocomposite membranes for fuel cell application. I mean, yeah. And I have sent you an email regarding PhD supervising opportunity. I
Wow.
would be honored if you
Sure.
could kindly review it. Thank you, Professor.
Yeah, no problem. Thank you. Thank you. So, to answer your question, yes, there's 100 or 1,000 of research papers and research center are doing research on nanocomposite. Whatever they name it, but it's still nanocomposite. But the challenges is definitely whether you get the MOF or you get halosite or CNT. To me, that's not that difficult. But the difficult is, as you mentioned just now, the reproducibility. You know, apa-apa kita buat pun reproducibility. So reproducibility in membrane, my experience for the almost 30 years, 30 years experience is actually through practicing how to make the membrane. Say, for example, you choose CNT, carbon nanotube, or MOF, or halosite, right? I tested last time when I developed CNT in the lab. Wow, I got a lot of paper. Because those days, CNT is quite new. But the price of CNT is quite expensive those days. Now it's very cheap. I give you some tips just now. Reproducibility, one of that slide just now, I mentioned that not more than 0.5%. One of my slide. Have you seen that, right? So I show it to you back. Yeah. I don't know whether I can share. Steve can share or not. Here. So majority, in my opinion, whatever you do, whatever you can see, we tested a few for loading, right? Graphene, this is graphene. Majority, the nanomaterial that we use, you cannot add more than 0.5%. Be it, I've seen that Sarina asking the choice on nanomaterial. It's the same. MOF, my student just now, Mahfuz, developing MOF as well now. Halosite as well. I'm among the pioneer in halosite for membrane more than 10 years ago. Whatever material that you want to use, whatever the structural properties or performance that you want to study, to test, alhamdulillah, no problem. But please check the loading. Right? Say for example, you want to use MOF or CNT lah, halosite lah, whatever site. That is just, you would like to say that you are doing something new for your PhD or your master. To me, that is all. But the reality is, when you have that choice of material, you put into your membrane, can your membrane produce a good result as I show it to you? And they will ask you, when you test this membrane with that nanomaterial, how many hours you test your membrane? Is it 45 minutes? 2 hours? After 2 hours, can you keep on testing for 1 week or 3 days? Now people, the question is more inclined toward that. Boleh? Senyap je. Hello?
Got it, Professor. I get it.
Huh? Is it okay?
Yeah, we can hear you.
Yeah, that's my answer. Together, I think I also answer Sarina Hanifah as well. Yeah, from a structure component, what are the advantages of MOF now is the way forward. The structure, I'm not sure, but a thin film nanocomposite membrane, it's just the overall structure on top of the whole fiber or the membrane, right? The important thing is here is the alignment. Is it aligned tidur gitu ke atau menegak? Understand? The MOF structure, whether it is whatever structure, in my opinion, is okay as long as they deposited on top of the skin of the membrane. You have to measure the alignment on that. The alignment that will affect the performance. Ini saya punya PhD ya dalam bidang ni. Okay? Ada lagi soalan? Any more question?
Yeah, I think we have one more from the message box.
Yeah, this is I think I answered already, Dr. Sarina.
We have one more from Ibu Tuti. May I just
Tuti,
read the question? Yeah.
I have a question. Could you please explain how desalination process change hybridization of carbon atom in graphene from... Wah, ini saya tak boleh jawab ni. Sorry, saya tak boleh jawab ni. Dekat mana jumpa ni?
Ibu Tuti, do you want
Ibu
to
Tuti,
read
where you got
the
this? Where you found this SP2 to SP3? I have no experience finding this.
Okay.
Anyone can assist me?
Okay, she said the picture explanation on the left side.
Mana dia? Hold on,
Di page berapa, Ibu Tuti? In which page of the slide? 24, Prof. Slide number 24. And
oh, this one?
yeah. Oh, okay. On the left side, under the picture, the synthesized graphene oxide. Is it?
Oh, this one?
Yep. Yeah, I think
okay. This is because of the structure that we choose.
Salah kali, ketukar kali sama yang di bawah raknya. Soalnya di bawah ini.
Yeah, please go ahead, Prof.
Yeah, it is because of we choose the state resulting change because of the structure of the graphene itself. So when the structure that we found, and then we introduce the during the layer by layer add on the fiber, that will change layer by layer, because in thin film nanocomposite membrane we develop layer by layer. This is one of the technique to produce the membrane, and is only applicable to a certain material such as GO and probably MOF. Before this, if you use just a normal material, you don't need layer by layer. When you put this fiber, this is a nanomaterial layer by layer, it will eventually change the structure of the thin film nanocomposite membrane. So it must be through layer by layer technique. Ada lagi soalan?
Any other questions from the floor? Anybody?
Mr. Bambang, Pak Bambang tuh.
Pak Bambang?
Bambang the
Silakan Pak
Membran
Bambang.
researcher Prof Universitas Negeri Jember, Prof. Mr. Bambang, they our
Oh,
Iya.
oke.
classmate. Bukan kakak kelas ya, brother. Silakan Pak Bambang. Chairman of HKI
Okay.
Jakarta ya, Pak. Jawa ya, Pak Bambang ya. Chairman HKI Jawa Timur
It's
ya.
Java, yes.
Iya, it's Jawa. Mr. Bambang. The riset kan Membran masih ya, Pak Bambang ya. Iya.
No, I to apa composite too, but not
Composite.
membrane application, but to assertion future.
Iya. Thank you Pak Bambang join our seminar.
For your information, I'm also advisor for Indonesian Membrane Society. They
Yeah.
just established it sometime in May in Undip. Because I think there are many more membrane researcher in Indonesia compared to Malaysia. But how come they do not have Indonesian Membrane Society? So sometime last year, I'm chairing a international conference. The first time Malaysian was given the opportunity, ASEAN and Membrane Society. So saya galakkan mereka tubuhkan Indonesian Membrane Society. This is very important. So alhamdulillah, they already established, and the chairperson is Profesor Tutuk Joko Kusworo. Kenal tak? Ada kenal?
Iya.
Ada
Undip,
Profesor
ya.
Hamzah Fansuri.
Oh, Pak Hamzah ya.
Not
Pak
present,
Hamzah
yes,
is
not present. Yeah,
Vice President.
Pak Hamzah.
Yeah, Vice
Yes,
President.
from ITS.
Yeah, ITS.
Yes. Okay.
Any burning question from Pak Bambang probably? Membrane technology.
Before I research in the ultrafiltration membrane, but so moved in the composite, but especially for assumption
Oh, good.
with the biochar modification, not
Wow.
membrane. Okay.
Yeah. Because biochar now is very important because especially orang Jepang,
Oh, yes.
they develop biochar a lot. They can see that this is the future for any technology, not only in membrane, especially in photocatalytic,
Yes.
They use this a lot. So I suggest kalau ada ramai orang buat a group lah di Indonesia untuk biochar ni, because I was informed Indonesia have a lot of biochar, the thing that can produce biochar. This is my honest. I was informed by my Japanese counterpart.
Okay, thank you, Prof.
Okay. Thank you, Pak Bambang.
Yes, thank
Another
you.
question from the floor, from the participants, probably.
Dia ada satu lagi.
Ada satu.
Majuro, and I am currently conducting doctoral research. Mixed matrix. Good.
Ya, Prof.
Yeah. Natural clay. Clay. Yeah, please go find a clay mineral. Because I use halosite, I mentioned just now. Very, very cheap. Because when I use halosite, I can compare with CNT. Very expensive those days. That's why when I produce with my PhD student from Iran those days, now dah jadi dekan dah di Iran. So we receive a lot of citation. Because the halosite is very cheap. In analysis, it may also indicate uneven filler dispersion during membrane formation. No, biochar, insyaAllah, if Bu Majura use very small amount, 0 point something, 0 point something.
For
Inshallah.
my case, start from 0.25, 0.5, and 0.75. So the optimal condition right now is 0.5%, Prof. But
based on the result of ADS, explained that the mineral clay from the ADS can distribute homogeneous in the top of membrane, but the in the cross sections, this is like a randomized or heterogeneous like that, Prof. So going on to do the performance membrane, how to keep the permeability but still how to keep the selectivity but still maintains the permeability.
That is the thing that we as a membrane technologists, there's the way forward challenges. Now you need to know at what temperature when you try to incorporate that on the membrane, at what temperature, right? Ini penting juga suhunya berapa gitu kan, and you use flat sheet or hollow fiber?
For today still flat sheet ya, Prof.
Okay. Kalau flat sheet tu masa you cast atau masa you try to incorporate this apa namanya nanomaterial, selaju mana? How fast?
Directly, Prof. So after I finish the DOP solution, lepas settle DOP solution tu, lepas tu saya buat casting tu to go to coagulation batch during 15 seconds. I just still wait 15 seconds and then go to coagulation batch.
The coagulation bath, what is temperature?
In the temperature degree just for about 25 until 27.
Okay. Probably you can check as well by varying the temperature of the coagulation bath and how long you put in your membrane in that coagulation bath. And before you create your dope solution, after you mix the things, how long you put that after mixing before you casting?
Okay. Before I ate polymer.
Ini the tips. Kebiasaannya, after you create your dope solution, you cannot immediately use it. You have to use it the next day. You allow those dope to casually mix around. Barulah you cast. Macam begitulah. Betul tak? Ke you pakai terus? After
my case, yeah. For my case, saya buat terus, Prof.
Cuba simpan dulu. Okay, coba simpan dulu. Ya.
Okay.
Kasih dia relax dulu.
Sebab so far saya guna solvent tu green solvent, so the viscosity of the solvent quite higher compared to NNP or DMF. So this is also my case.
Yeah, because why I ask you to keep until next day, from there you can see selepas itu ada naik tak material tu, ataupun dalam this could be one of the factor. Okay lah, kalau satu hari lama sangat, wait until 2-3 hours before you cast.
Baik, Prof.
Okay.
Thank you so much, Prof.
Thank you.
For insight.
Thank you, Prof. I think we have one quick question from Bu Shilda.
I use both, all single wall as well as multi wall. Single wall pun we use. Multi wall pun also we use. And it depends on the result. Then we can choose which one you want to move forward. Because it depends on the dope solution formulation. But of course, normally multi-wall will give you some good result. It depends on what application you want to use and what is the composition of your your dope that you want to mix to create. But ya, saya buat dua-dua sekali. Kebanyakannya multi wall lah, kebanyakan kami di sini lah. But ada juga kami buat single wall. It depend.
Like saya kerja buat aplikasi buat komputer
Apa dia?
yang kontaktif.
I cannot see. I cannot hear.
Ibu sudah suaranya breaking up ya. I think your internet connection is not stable.
Okay, tak apa kalau biasanya multi-wall carbon nanotube. So far, majority we use for wastewater treatment. Ada juga lagi kita buat yang lain juga. Single wall pun kita start juga.
Okay.
Dr. Samira?
Great. I think the time has reached us to the end of the webinar, and we have quite a fruitful discussion, not only Q&A session. I feel like it's more like the discussion, right? Quite deep discussion, some of the questions. Prof. Fauzi, it has been a true honor to have you here.
Thank you very much.
Even though it's virtual meeting, is our first meeting, right?
Inshallah.
Hopefully we have a chance more to meet in the future. As a small token of our sincere appreciation to you, it's our pleasure to invite our representative of HKI Jakarta, Bapak Afrizal, to present a virtual certificate of appreciation to you.
Thank you very much.
So please accept this certificate as a symbol of our gratitude for your valuable contribution to today's webinar. Bapak Afrizal,
yes,
time is
thank
yours.
you, Ibu Samira, thank you very much. Okay, Prof. Fauzi, thank you very much. So I'm very excited and good. Thank you for participant and very attractive, interactive question. This certificate of recognition for Prof. Dr. Ahmad Fauzi Ismail, speaker today in webinar. We give applause for Professor Ahmad Fauzi.
Thank you very much.
I hope we can invite maybe next year offline to meet together again to discuss and more deep about the Membran research about this. Okay.
Inshallah.
Okay, thank you.
Terima kasih banyak.
Yeah.
Thank you again, Prof. Fauzi.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Take
Okay.
care.
Maybe we can take a photo again, or maybe
boleh.
I've just
Sure.
Sebentar. Diarahkan Pak Irwanto ya.
Okay. Yeah.
Shall we invite everyone to on their camera? Probably.
Tunggu dulu sebentar ini.
Please open your camera to all our participants. Yes, we are going to take a picture. We already have 2 screens, and we'll start with 4 screen. 1, 2, 3. Thank you. And the last screen. 1, 2, 3. Okay, enough.
Okay, thank you so much.
Thank you
for joining us today, for your active participations, especially during the discussion sessions. So I think on the behalf of HKI Jakarta, Dr. Afrizal, Dr. Irwanto, we would like to thank you all. Thank you for today's webinar. I think we hope we can see you again in our next webinar, hopefully. Thank you, everyone.
Thank you very much, Prof. Fauzi.
Salam. Thank you so much, Prof. Fauzi.
Samira, Pak Irwan.
Bye-bye, everyone.
Bambang, thank you for join our webinar and the other.
Thank you, Prof.
Terima kasih Pak Afrizal.
Terima kasih.
Thank you Prof. Fauzi.
Thank you, Pak Afrizal, Mbak Samira. Thank you.